In this question, the graphs of y equals mx plus c and y equals ax squared will have no points of intersection for all values of m, c, and a, such that, and one of these. So the easiest ones to look at first are these shorter ones, a, b, and e. So looking at a, so if a is greater than 0 and c is greater than 0, so that means the a here has to be positive, which means the parabola, and that being a quadratic, means it's going to be upright with a positive a value and can be different shape widths, if you like. And for C, this y-intercept here to be greater than 0, it means the line's going up here somewhere. It's definitely going to intersect. So A is not the answer for this one. B, A greater than 0 and C less than 0. Well, if you had the y-intercept less than 0 down here, it hasn't specified a value for m, so the gradient could be anything you like. And so it would be possible even with a negative y-intercept for that line to go up and through the graph for some values of m. So because that's going to happen, it's not going to not intersect for all values of m for that particular case where a is greater than 0 and c is less than 0. So B is not the answer, and C I'll get to a bit later, and E, M is greater than 0 and C is greater than 0. So in this case, the gradient is positive and the y-intercept is positive. So that would mean you would have something like, so the gradient is positive, so it could be going anywhere but not horizontal, and C must be greater than 0, so it could be doing that. And even if A was negative, which would mean an upside down parabola, it may not intersect, but if it's upright, it's definitely going to intersect no matter what the gradient is, as long as it's positive and the y-intercept is positive as well. So E is definitely not the answer. So looking at C and D, both of these have an inequality in them, and the inequality connects all three variables M, C, and A. So what you need to do somehow is get an equation that does connect those variables, and the easiest way to start that is just by letting these two equations equal each other. So you would have ax squared would equal, or let it equal, mx plus c, and that in fact is the first step when you're trying to find the points of intersection. So from here, what I would do is move these to the other side, so minus mx minus c equals 0, and then what I want is no points of intersection, so no solutions to that equation, and that happens when the discriminant is less than 0. So that's the first step here or the next step, to find what the discriminant equals and then somehow get one of those two from there. So first of all, the values of A, B, and C. So A is equal to A, B equals minus M, and C equals minus C. Subbing them into here, you get minus M squared for B squared, and then minus 4 times A times minus C, and then that equals M squared plus 4AC. And so what you need to do next is go M squared plus 4AC is less than 0, because that's what you need to happen for no solutions, and then rearrange this until it looks like one of these. So because these are in terms of C, or C is the subject, I'm going to keep this term here and move m squared to the other side, so you get 4ac is less than minus m squared, and then divide both sides by 4a, and you will get c less than minus m squared on 4a. However, so that's actually this side of the inequality, which is correct. However, the sign is not pointing the same way. So this is C greater than that. This is C less than. So the only way that this can become greater than is if the A was in fact a negative number, so that when you divided, the inequality sign would change. And that in fact is what would happen or needs to happen. And so for here, you would then say, as long as A is negative. And so now it's pointing the right way, and that's the condition for it to point that way. A is less than 0, and that's this one here. So if A was positive, when you divide by a positive, that sign is not going to change, but it does when you divide by a negative. So that means that D is definitely the answer for this one.